Okay, let's take a look at synthetic division of polynomials. And we're going to use it to find the roots of the following polynomial. So if we look here, we got this polynomial, right? And we're not really given any other information. So what we need to do is we need to get a root that we can synthetically divide out, and then we'll be down to that root and x squared, and then we can solve the rest of the problem. So let's take a look at that. How do we find numbers to divide out? Well, we got to test the factors of 15. Okay, so let's start by writing out factors of 15. So first we gotta kind of list these here and try them out. So we got obviously 1 and 15 is one way to multiply, and only one other way, which would be, actually let's write the 3 first. You'll see why in a second. We're going to have plus or minus 3 and plus or minus 5. Okay, so I'm going to go ahead and I'm going to now test. And how I test is I just input the number and I need to see if I get 0. If I get 0, what it means is that that value is 1 comma 0, and that would mean it's on the x-axis. But let's see if it is. So I'm going to go ahead and test 1. I'm going to input for x. I get 1 cubed minus 5 times 1 squared plus 1 plus 15. Well, that's going to give me 1 minus 5 plus 1 plus 15. And I can already see, I mean, this is going to be a positive number. It's not going to be 0, so that's not going to work, right? We need to get a 0 in order for this to work. So let's test now. Let's test negative 1. All right, so I'm going to go back, try this again. Negative 1 cubed minus 5 times negative 1 squared plus negative 1 plus 15. Okay, well, that's going to give me negative 1 minus 5 minus 1 plus 15. Okay, well, that's not going to work either because I'm going to get, 15 minus 7, and that's going to give me 8, so that's not going to work. So let's try this again. All right, now we're going to go back and let's try next number. Let's try with 3. Okay, let's see how it goes with 3. So I'm going to input 3. I get 3 cubed minus 5 times 3 squared plus 3 plus 15. All right, this is looking a little better, but let's see if this works out. 27 minus 5 times 9 is going to be 45 plus 3 plus 15. Okay, so we're looking good here. Let's just double check this. 27 plus 30 is 30 plus, or sorry, 27 plus 3 is 30. So 27 plus 3 is 30 plus 15 minus 45 means 0. So we have a winner, right? So that means x equals 3 is a root of the function. And it also means that x minus 3 is a factor that we could, divide out of this. Now I'm going to use the root to do the synthetic division. And I like that better because we can use a plus sign here. So here's how I'm going to set it up. I'm going to say, all right, well, I know that x equals 3. And now I'm going to take the coefficients of my original polynomial up here, and I'm going to synthetically divide them out and see what we get. Okay, so first coefficient is 1, because it's just x cubed, then negative 5, then 1 again, and then 15. Okay, so here's what I'm going to do. I'm going to move that 1 down, and now I'm going to start the synthetic division process. Now, this is kind of the crucial part. I'm going to put a plus sign here, and we'll see why in a second. And here's the motion. 3 times 1 gives me 3. So I record my answer, right? I go over here. That gives me 3. Negative 5 plus 3 is negative 2. Okay, so now I've done the first set, and now I'm going to repeat this whole process. Now I'm going to say 3. I'm using 3 all the time to multiply. 3 times negative 2 is negative 6. And now I'm going to say 1 minus 6 is negative 5. Okay, and now I'm going to say 3 times negative 5 is negative 15. And as I was hoping, right, if I do this right, I should get a 0. 15 minus 15 is 0. And so I've done this right. Okay, so I have x equals 3 now factored out. And now we're going to write our new function, and we're actually going to have to keep going here because we still need to figure out, right, we're supposed to find all roots of the following polynomial. Well, we know that x equals 3 is a root, which means if x equals 3 is a root, that means that x minus 3, so x minus 3 is going to be a divisor. And then I have x squared minus 2x minus 5 is, notice what I'm doing here is 1 degree less, and I'm taking my coefficients here. Okay, so I look at this, right, and in a perfect world or in a better world, we would at least be able to factor this, right? But I can't factor this, so I'm going to go ahead and just go use the quadratic formula and get my answers here. So negative 2, so negative b plus or minus b squared minus 4ac, but I'm just going to go ahead and input those numbers and so we can figure out what we got here. So negative 2 squared minus 4 times 1 times negative 5, and that is all over 2 times a, which is 1. And so I'm going to have equals 2 plus or minus 4 plus 20, right? So I'm going to have 4 plus 20 over 2, and we'll just simplify this and we'll have our answer. That's actually going to give me 1 plus or minus, well, square root of 24, we could divide out 4, and so we would actually have 2 square root of 6 over 2, but we could just rewrite this as 1 plus or minus square root of 6. Okay, so we have our 1, 2, and 3 are really 2 solutions here, right? Yeah, and I did that kind of fast, but just know what I was thinking in my mind was I was thinking, well, 2 over 2 is 1, and then plus or minus square root of 4 times square root of 6 would be 2 square root of 6 over 2 as well. Okay, and then the 2's all cancel out, and you have 1 plus or minus square root of 6. So I have 1, 2, and 3 solutions, and I found all the solutions of this polynomial.